Okay, I think we could maybe start. So thank you very much, everybody, for coming. And as you all know, today it will be an English workshop due to the fact that we will mainly present European research projects. So we will have European colleagues and guests here in presence and online. So I will not steal that much time from the presenters of the projects. As you see, we have a pretty dense agenda today. Thank you very much for coming. This workshop is mainly a dissemination event for European projects. And today you will hear a bunch of different projects, all related to the world of polymers and the circularity of the polymers industry. We, as Barcella, are mainly involved in the composites industry. So the first two projects that you will hear from us will be related to circularity and waste reduction for the composite industry. And then we will hear many other very interesting projects. So we will hear from 8 different projects this morning, and then we'll have a pitch presentation and poster session in the afternoon. We will have a coffee break and then a lunch break at around 13. So basically that's it. We will try to find the time in the afternoon to have an open discussion about what we've seen today and potential remarks by everybody that's here or at home. So the first presenter is Michela Mattia from Rina Consulting.
Hello. So, thank you all to be here today. I'm Michela Mattia, and I work as a project manager in Rina Consulting. If you don't know Rina, Rina Consulting is a engineering consultancy division of Rina, providing different services to clients in different sectors. And today I will present Tool for Life project in the framework of this workshop. Tool for Life is mainly related to the tooling materials, then design and process engineering, and how to improve these aspects in order to improve the overall sustainability of composites. In particular, Tool for Life is a project that has been co-founded by European Union under the LIFE program. In particular, we have a budget of 3.5 million euro for the implementation of the activity of Tool for Life, and it is a 3-year implementation of project. We are now already in the last year of the project. The main location for the implementation activities is Varano de' Melegari, close to Parma here, where also our coordinator that just presented before is located. So Barcella is coordinating this project, and the overall beneficiaries are 4 from Italy and Belgium, and we are Rina, Centexbel, and Marbo. Okay, when we talk about composites, we can involve different application and different sectors. So this is a very wide topic. We can consider automotive, aeronautics, space, nautical sector, every sector where high mechanical performances or light material are needed. But when we talk of these materials, we have also to consider the issues of sustainability. In particular, in our project, we consider the issue related to the thermosetting resins that are used during the production of the composite. Considering this issue, we can estimate that only in Italy, more than 2,000 tons per year of thermosetting material are landfilled. It comes from the production of composites tooling. The idea of Tool for Life project is to improve the sustainability of composites, addressing an important pre-processing step of this production, in particular the production of the master model. Usually, when we consider the production of a composite product, at least in this case, we have to consider a process of 3 steps. First, master model is produced usually in the benchmark situation using polyurethanes or thermosetting materials. Then this master model is used to produce a mold that is finally used to produce the final composites product. In Tool for Life, we want to modify and optimize the methods, process, design, and materials for the production of this master model. The main objective is to develop and demonstrated an hybrid approach for this manufacturing, in particular using additive manufacturing and milling. This process will demonstrate a reduction of the total volume of material used for this process that is up to 80%. Furthermore, with the new process, we are able to achieve a cut of the energy consumption by 33% respect to the benchmark, and also a target of 9.2% of the CO2 equivalent emission. Furthermore, we will also demonstrate a fully retrofitable and recyclable product for the master model. This will be done converting from the typical production process that consider a polyurethane tables that is milled to the final product, with a fully circular value chain that use also thermoplastic materials that are also reusable. This is our process. So the first step in the production of the master model is the production by additive manufacturing. Already this step allows to reduce a lot the mass of material that we are using in the production of the item, and a final milling in order to reach the final shape needed for then produce the final composite product. After the use of this mold, the innovation of this process is that using thermoplastic materials, it is possible to shred this product again. If needed, a new compounding is made with virgin material or other additives when needed, and it can be used again to have new pellets that are used again in the additive manufacturing process. Our project in its execution is divided in 4 fundamental steps. We are now already at the end of this project, so the first step is completely done again already, and it's the design, the procurement, and the commissioning of the overall pilot. Then the 3 subsequent steps are now ongoing, which are the producing of the different tooling to demonstrate our technology, the study of the recycling process in the additive manufacturing, and also the sustainability assessment that allow us to demonstrate the positive impact of this project. In particular, These slides want to show the role of the different partners. First of all, the first step of this project was to identify which is the best thermoplastic alternative material to be used in the additive manufacturing. This work has been done by Centexbel. Then the second step was the development of more sustainable water-based sealants, in particular primer and release agent for the use of the tooling, and this has been done by Marbo. Then there is also the study of the recycling process and how to optimize this process. This is currently ongoing and is done by Centexbel with the support of Bercella for the pilot scale. Rina has the role of the topological optimization of the master model in order to use as low volume of mass as possible during the additive manufacturing, and also we are performing the environmental, economic, and societal sustainability assessment of this new technology. Vercella take care of all the demonstration and testing activities of the overall system, so from the production to the recycling of the process. You can see that the pilot is now working and operative, and we are now starting the validation phase. So the final here, we will demonstrate that all the results of the project are effectively working well. This pilot is, of course, located in Vercella facility. So here I wanted to give you a overall view of which are the impacts that we can have with this new technology. First of all, a huge waste reduction. In fact, the new process, respect to the state-of-the-art process, can reduce up to 20% the volume of material that is landfilled at the end of the process. Furthermore, the use of additive manufacturing can reduce a lot the energy consumption that in the previous process was mainly related to the machining of the tooling. Then we can, with this process, completely avoid the use of toxic chemicals such as isocyanates that are used in the polyurethane production. And also, we reduce a lot the CO2 equivalent emission. If we consider a medium-sized tooling with the state-of-the-art production process, we can say that it releases around 685 kilograms of CO2 equivalent. With our new process, we arrive to 63 kilograms of CO2 equivalent per unit. So it's a huge difference. And we hope, and we already can see the results that also these new businesses and the increasing of the one already existing can bring also new job opportunity in the sectors. If we want to see our project in a more large view, we can say also that all these results are completely in line with the overall European policy and roads that we are all these projects are following. In particular, we are completely in line with the Green Deal and the objective of circular economy and zero pollution and toxic-free environment. As a last, let's say, slide, I wanted to show which are our idea, let's say. We really would like that Two for Life is not just a project, but it can bring more impact also in the future. So we are expecting that, of course, in the short term, the mainly results that we will have is the production savings that you already saw in the previous slide. But we hope that finally this tooling can be used also by others using a tooling as a service exploitation strategy. and then in the future that others could use also this technology by licensing, so more medium to long term. So finally, today all the partners of Tool for Life are here. So if you have any question, you can do it now or later, also in the poster section. You can subscribe to the newsletter of Tool for Life on the website, and through the QR code, there is also the LinkedIn page. You have my contact, and thank you. We will have a few minutes to answer all the questions to the presenters. So we will go ahead with the second presentation. Also for the people listening online, please write in the chat your questions. We will try to answer them at the end of the session.
Okay. Welcome, everybody. I'm Michele Morvarigazzi from Bercella, and I'm mainly involved in developing new technologies. Tool for Life and Zero Waste Life are an important occasion, chance for us in order to investigate new process in order to guarantee mainly the sustainability of composite. I will proceed with the presentation of the Zero Waste Life, that is a project that want to investigate the possibility to improve the sustainability from the other side of the circular economy. So avoid the waste of materials, of raw materials. So we start from the beginning and not from the end of the use of composites. A few words on Bercella. We started with Franco about 30 years ago. You can see some of our important steps, and we are a quite important producer of motorsport carbon fiber parts. And the new era of our activity is starting with important role in aerospace. The last important innovation is the adoption of large-scale additive manufacturing that Michela told before. In a few words, we are a medium company of about 100 employees. Here you can see some numbers, and we have an important development plan because of the next year we will have a new plant mainly dedicated to aerospace production, space production. You know almost all of the large-scale additive manufacturing. We have an important machine with a printing volume of about 3 by 2 by 1 meters, and Michela described very well his function. We have also an example over there of printed polymer in raw and milled form, and we can discuss about the technology afterward. The Zero Waste Life project see three beneficiaries, three partners. Bercella is the coordinator. but also Nobrac in France, located in Montauban, near Toulouse, in the very center of the aerospace production of France. And an important role is played by RINA, located not only but mainly in Genova. The project is a 3-year project. We are at 15 months from the beginning, and it's a quite important project. You see the budget related to the project itself. What are the main objectives of the project? The problem we started from is that the traditional technology of producing CFRP, carbon fiber reinforced polymers, is characterized by an important waste of raw material, mainly related to the cutting of the prepregs or the tow, because of I think you know that the traditional way to have your shape is to cut from virgin fabric of carbon fiber. We use prepreg, so also mixed with the epoxy resin we cure in autoclave. But in this phase, even in spite of heavy optimization of the cutting process, still a very important amount of material is wasted. And we estimate a value between 30% to 50%. So now on average, 40% of material is wasted. And here it's there is a couple of pictures explaining this concept, and it's pretty clear that realizing this kind of geometries, it's a nightmare with the traditional technology, because of it's very, very it's a pity to waste this, and it's also an economic impact on the company to waste all this kind of material. It's clear. The size of the problem is very important, because we can consider that globally we have manufacturing of about 1 to 1.5 million tons per year, increasing from 6 to 8% yearly. If we consider that this is the production, we can calculate that the raw materials from where we started are between 1.6 to 2.4 million tons. And so the volume we waste is in the range of 0.6 to roughly 1 million ton. So these are the number of the waste in all over the world. And if we consider only the European area, such values are expected to stay in the range of 150 to 220 kilotons of volume waste. What is the objective of the project? The key target is to demonstrate that the manufacturing of composite, of three-dimensional shape composite with high mechanical performances, can be performed through optimized amount of material reducing the wasted volume near to zero. And in a couple of minutes, I will describe how we can realize this objective. The near-net shape design of the structure and the flattening process is realized by a new, fast, not very new, but I will explain, fast and reliable process named a high-volume tailored fiber process placement. And the main aspect of this technology is to place the carbon fiber, in our case, exactly in the position we need, so in the direction of maximum stress. An important role is the topological optimization of the geometries in order to have lightweight structure, but with high mechanical performances, so high stiffness. The process is here described, and the sustainability is mainly related to avoid the waste of materials at the origin. So we use almost 100% of the material. So at the end, the process is not a process with high productivity, but at the end is a cheaper process than the traditional one. And another important aspect is that the final product we obtain needs only finishing activities. The optimization process is supported by the use of a modular concept. I mean, the final shape will be reached leveraging the use of three basic elements, beam, plate, and shell, in order to realize the complete final shape. Just to give you an example of the idea behind this concept is the tower crane. So we can consider a tower crane realized only by beams. So this is the idea. Our solution is realized with HV TFP, so high volume tailored fiber placement. That is a sort of stitching machine, pretty complex, but you have the fiber, in our case, the toe preg, so a single fiber or a small group of fiber placed on a surface, and they are immediately fixed, blocked in the right position by a very narrow stitching wire. And this technology is very suitable in order to realize geometries with trabecular shape or honeycomb geometries and so on. So when we have geometries with voids and so on, here we have the maximum of our performances and results. The process is divided in three main steps. So first steps, starting from the three-dimensional CAD shape, is flattened with 2D process. And we starting from a topological optimization of the three-dimension shape in order to identify where we have to place the line along the maximum stress direction. Then there is the manufacturing with HVTFP machine, the realization of the preform. This is the name of the bidimensional parts we are considering, realized with the combination of beam, plate, and shell shapes. And then we will investigate the possibility to cure this kind of preform, obviously positioned in a mold, in autoclave, but also with other curing technology like press or resin infusion. So this is the technical aspect of the process. Here we have some example of geometries with high yield. It's pretty simple to understand why these geometries are good, because of we have many voids and we have to identify the line on which we direct the stress of the pieces of the parts. And it's easy to understand that with traditional fabrics where you have defined 0, 90 degrees direction of the fibers, it is not optimized the position of the fiber along the stress direction. With TFP, you can realize pretty well this kind of, you can obtain this kind of results. So here we have my information, my contact information. Please feel free to contact me whenever you want in order to have much more information about Zero Waste Life or other information on composites.